so you see that I've expanded the search, and I've got things, I've got now a sort of a fuzzier distribution of if you look at ages, we're going across a wider range, and the same thing with weight. So again, it's sort of expanded it, but it has brought things back that are close to this patient in other ways. And so then one of the next thing to it, and this is kind of the real cool piece of it, is to say, now let me take a couple patients that I like in here, and you can pick as many as you want, and you say, okay, now these are really, if I want to think about it, these are the patients I'm looking for. These are the canonical ones. So now then can I go expand this search and find more like me based upon clinical similarity. So there's no demographics involved in this, et cetera. It's all algorithmically clinically similar. So the researcher would go through this expanded list, select the ones that he thinks are closest to the type of patient that he's looking for, and then he would say, okay, now go find me more like this. But it would use, instead of the original limited sort of information that he put in on his inclusion criteria, it uses the complete record for each of those patients and then pulls back similar ones to that. And then we do some color coding so you could kind of see similarities between the two things. Again, for those of you who use Inspector, this should not be a surprise in the sense of color coding to show similarities and differences. Scores over there that show how well it matches one or the other. So this gives the researchers a way to go through and find patients for clinical trials and do so in an efficient self-service way. We can, we also support exact queries, et cetera. But I think the key to it is to be able to do the more like me. And again, that's the things for not only clinical trials, but if I want to find, there's a patient that just came in, finding more like that particular patient if I'm interested in looking at coordination plans or treatment plans or outcomes. So again, it's a way of operationalizing clinical data and getting it into the hands of the researchers, of the informaticians, as well as operational personnel. So that sort of is an example of what it does. Let's take a quick look at what it looks like in terms of an architecture point of view. And so go with this. Let's start in the middle and move out, because the middle is really the MDM solution that we all know and love, slightly modified. So that is the MDM solution. So it's a standard initiate, what we call standard edition now, data engine. And we have configured it with our clinical data model. We have added in there this ability to do patient similarity. And one of the things that we introduced several releases ago within back when we were Initiate, was the notion of, well, we want to do more flexible searches than are supported by perhaps just the algorithm. And so the way we did that was we added the capability of creating a full text index or a Lucene index. That's the type of thing that Yahoo and Google use to do text searches. And so that's an option now within MDS, and we've used that option as we've built out this clinical hub. The other component, one of the components which is new, is that we call it an MDSI, and it's an interface that's really specific for clinical information. And so rather than just, we always had data that we could derive web services and derive Java objects for an API from the data model. But here we've gone to the case where this is complicated enough, especially when you talk about inclusion and exclusion, is that we created an API sort of specifically for dealing with clinical information that also hits the Lucene index, et cetera. I mentioned vocabulary index and reference data management. That's a key part of it. We have solutions within the Infosphere area, RDM, and we're building that component in with this one. But so the centerpiece with the security and user management essentially is what you know and love as the Initiate EMPI, but with a completely different data model, some new search capabilities, different set of algorithms, and some new APIs. At the top is one of the data collection, and the data collection here is of course much harder. We're building around WebSphere Message Broker, and incidentally, we're shipping WebSphere Message Broker with our next release coming out this quarter, which is in 10.1. So you can start to use that technology for doing managing of HL7 messages, etc. And the good thing about that is that that's a technology that we're using across IBM as well as for this particular application, but for other pieces. So the WebSphere Message Broker does the HL7 parsing, if you want, and then within that we have added a couple key features within that technology. We have added one. And I'll explain this one on a separate side, a way to de-identify information within the HL7 message before I pass it into the Clinical Hub. And that, of course, ties over to the EMPI, where you're normalizing MRNs, et cetera, to enterprise identifiers. And then we have, as part of that, we go through and we parse the clinical messages. We also have really a very specific text mining approach that we use for healthcare data to build out and take the information from the unstructured components within the HL7 messages and structure those in such a way that we have those available within the Clinical Hub. As a quick aside, one of the issues is that anything that you're doing with text mining or inference from text, you have a higher chance of errors than you do if you think if you get a declared thing. So we highlight that information when you're getting search information back as to what information has been inferred from text and what information is declared as part of the structured data.